Good day, everyone. We're here again. It's Nip again here with another Q&A. We've posted a Q&A from Mike Holt's page, wherein we're asking if it's okay to have a 10 gauge wire for a 50 amps breaker. This one is for air conditioning units. So here are the results of it. Checking on the results, it's 43% yes and then 57% no. So we've got a higher vote for no. Well, we'll see, is that right or no? Okay, well, we'll have to check if what is the ampacity of 10 gauge wire, and if we look at it, it's size around 10 gauge, and we'll assume that we'll have 75 degrees temperature rating of conductor, since because of the temperature limitations in article 1. Okay, 10 gauge will be 35 amps, so that's the case here. We just have to delete this. This is the scenario now, since 35 amps. So is it feasible to have this breaker to protect the conductor here? 35 amps, 50 amps, and we will look at it. Oh man, 50 amps is just too far from 35 amps. Is that possible to be used for air conditioning units? Well, a lot of people say that, yeah, you must put in a big wire for that, but some may say that this is enough. So let's check the different code rules that pertains to this. Okay, overcurrent protection, article 240 and 240.4, it's the protection of conductors. It says that conductors other than flexible cords, flexible cables, and fixture wires shall be protected against overcurrent in accordance with their ampacities specified in 310.15, unless otherwise permitted or required in 240.4 A through G. Well, we're not going to run down from A to G, but let's see some of it. Letter D. It's about the small conductor rules. It says that unless specifically permitted in 240.4 E and G, remember, E and G, so everything will be under small conductor rule except those E and G. No? The overcurrent protection shall not exceed that required from D1 through D7 after any correction factors for ambient temperature and number of conductors have been applied. Okay, well, in this case, if we're going to apply this for a 10 gauge wire copper, let's just assume that we have a copper 30 amps breaker is just the maximum that we can put onto it. So 10 gauge copper wire for a 30 amp breaker only. So does that mean that the 10 gauge wire copper is not good enough for a 50 amps breaker, since we have a 35 ampere ampacity for that? I don't think so. I don't think so. Based on my research and through my experience, air conditioning units are not under the small conductor rules, right? So we'll just have to X this, not applicable to air conditioning units, since air conditioning units are actually under 240.4 G, wherein there is an overcurrent protection for specific conductor applications. Overcurrent protection for the specific conductor shall be permitted to be provided as reference in table 240.4 G. And if we look at table 240.4 G, yes, air conditioning units has their own way of being size. Air conditioning unit conductors and circuit breaker are based on article 440 and not based on small conductor rule. So it's a good thing to know that there's a different rule for this, and it applies also to other specific conductor applications, such as capacitors. We have electric welders, of course, fire alarm circuits, phase converters, and motors. Yeah, so a lot of it. They have specific applications. So let's check more. It's at Article 440. Thanks, Mr. Bin. Okay, I have just noticed. Just don't mind this, okay? Don't mind. I forgot to really, I forgot to try to remove that. The caption should have been air conditioning. So yeah, never mind about that. I'll just have to put some drawing here. Yeah, not that. Just don't get it. Okay. So rating or setting for individual motor compressors. So 440.22, it says that the branch circuit and short circuit and ground fault protective device shall be capable of carrying the starting current, right? Starting current. We all know that for a motor, a motor on direct online starting, it starts with a high current, right? Well, that high current isn't supposed to last long. It might be just for a few milliseconds or seconds. Um, then it will be going back to a normal current. So in such cases, the breaker is technically sized a little bit bigger than the conductors, just like this. That's why we have this. The protective device having a rating or setting not exceeding 175% of the motor compressor rated load. Oh yeah, so 175%. But we're also allowed, if it's not sufficient for the motor to start, let's say you have the motor, you've set it at 100% times the motor compressor rated load current, and still the circuit breaker still trips, then you're allowed to increase that up to 225% of the motor rated load. Okay, so in essence, we're talking about 175%, of course, times the current, right? Oops, let me change this a bit. Short circuit ground fault times the rated load current. Okay, just the current. I just put I here. It's the rated load current of the uh, motor compressor or the aircon units. That's the minimum. Okay, and then 225%. That's the max. Okay, that's the max. So you have a range of around 175% to 225%. So that's your range. Just delete this for a while. Okay. Next, motor compressors with or without additional motor loads. This is about motor compressors with other loads, such as on air conditioning. Let me just skip here so that you can see, because usually air conditioning units typically have multiple motors inside of it, not just the compressor. So an air conditioning unit works like this. It has an air compressor to compress that air to make it hot, from cold air to hot air. Then we'll have to condense that, but in order to condense the air, we need this. Okay, that condenser, it's a fan, I guess. So usually the compressor is larger than the it's technically larger than the condenser. Okay, we'll go back with that. Now let's see. It says that conductor supplying one or more motor compressors with or without additional motor loads, which is just like the condensers, shall have an ampacity not less than the sum of each of the following: sum of the rated load or branch circuit selection current, whichever is greater, of all motor compressors; the sum of full load current rating of all motors, 25% of the highest motor compressor or motor full load current in the group. So it just says that all the motor loads plus 25% of the highest rated motor compressor or motor in that group. Okay, we'll see that in the next examples as we ride through this. Okay, we have here an example. It has a, this is the air conditioning unit here. Okay, then it has a nameplate here, and the nameplate is zoom out here. 60 hertz full load amps, 18.5, that's for the compressor, and then the 3.2 full load amps is the condenser motor, that's why it's CD. Then on this nameplate, the maximum and minimum circuit ampacities are already given. These are called the branch circuit selection current, and usually air conditioning units have this. And if you have this, you are supposed to use this rather than calculating it. Okay, so for example, 40 amps, that's your maximum breaker or fuse size, and then 26 amps, that's going to be your minimum circuit ampacity. So what could be the answer here? Yeah, I was talking about this, 40 amps. Okay, I know it has been gone, but let me see. Let's go back. Okay, it's gone. Okay, it's gone. Okay, I'll give you an example here. We have a maximum fuse or breaker, then we have the minimum here already set by the manufacturer here, and then on the US we have 20 and 25. If you are in Canada, then 20 and 25, and they're the same, so don't have a problem. This is for the sizing of the breaker here. That's for the breaker here. While for the minimum ampacity of the wire, that's going to be the 14 amps here, minimum circuit ampacity. So if we're going to base ourselves here at 70 degrees Celsius rated conductor, then 14 amps will be here, 15 amps. So 14 gauge will be enough for this. So I'm sorry, I'm gonna write here 14 gauge. Okay, this one is enough for this 14 gauge. While the circuit breaker, based on the table on the code or what standard size for circuit breaker, 20 amps will be a good one. So you have now a 14 gauge wire on a 20 amps breaker. Just look at it. The ampacity is 15 and you have a 20 amps. So your breaker size is larger than the conductor size ampacity. Is that okay? Yes, it's okay. Based on the code, that's okay. Might look suspicious at the first time you see it, but that's how we do the minimum sizing of it. Okay, next, this pic came from Sparkys, so make sure to try to follow him, guys. He posts a lot of pics there and videos, good stuff, actually highly recommended here. This is, he sent me this photo. It's from one of his projects. Let's see, we've got compressor and a fan motor here, but we won't look at that. Just don't look at that. Let's look at the minimum circuit ampacity here. That's 18.3. Okay, so if it's 18.3, then a 12 gauge will be okay. So that's it. And then the maximum breaker here. Here the maximum breaker here, fuse 30 amps, 30 amps. Just look at it. We have a 20 amps ampacity for a 30 amps breaker. Is that good? Yes, it's good. I don't see anything wrong with that, as long as we're following the code, and in this case we're following it. Okay, what's next? Same thing. We have here a the maximum amps here, minimum circuit ampacity, that's 24 amps. That's going to be 10 gauge wire. Okay. And then we have the maximum overcurrent protected device, that's 40. So just having a 10 gauge wire on a 40 amps breaker sounds good to me. Okay. Okay. There are two things that we can learn about this. One is that we can follow what the nameplate is saying to us, which is this one. This is based from the manufacturer. That's their recommendation. If you have that, just follow that, okay? But there are times that this is not given, so sometimes you won't see some of these, and I've been experiencing that in the past. So you are required to calculate that. And how do you calculate that? Well, it's just easy, just like this. We've got the 18 amps here. This is for the 18 amps is for the condenser, of course, or no, the compressor. Sorry, that's the compressor. And then the 33.2 amps, that's for the condenser, because a while ago we talked about this, that in air conditioning unit you have multiple motors inside it, and usually the largest of it is the compressor, since compressor needs a lot of power to really heat up that air. Okay, so basically the rule we talk about, 125% of the largest motor, so that one, 18.5 here, that's 18.5, so it's going here. Okay, that's a good one. And then the remaining motor loads, that's 3.2, that's going here, and then add it up, that's 26. Just in case, you can pause this video, then check the code articles here. That will give you the proper proof. Where did we get the sizing of the conductors and the circuit breakers also, and it applies to all. Okay. Next, selecting the conductors. Well, based from the table again, 10 gauge. Okay, so that's good. We don't have any problem with that. 26 amps is our calculated, so 10 gauge. Remember, 10 gauge copper. We have 35 amps rated. Okay, that's 35 amps ampacity, right? Based on the table a while ago. So yeah, check that code article. Then for the circuit breaker, we're sizing for the largest possible, so 225% of 18.5 here, plus the remaining load 3.2. So yeah, 44.8. But remember that what we calculate here is the maximum, so we are forced to go down a bit, so use a 40 amps breaker. Remember, we talk about maximum size, so we can go back to that slide so that you can see it here. Remember, it's maximum since we have calculated something that's larger than 40 amps, then 40 amps will be good. This one, whichever is greater, wait, where's the term that says it's maximum? There's a maximum here. I don't know. Okay, let's go back there. So the size, the final size here is 10 gauge and a 40 amps breaker. Is it the same as when we get base here? Maximum size 40 amps. Yeah, it's the same. And then 26 amps. Yes, 10 gauge is possible. Okay, so either way, you're good. You're good at it either way, but it's better to follow what the manufacturer says. But if the manufacturer doesn't give you this, then you're forced to calculate it. Okay, almost the same result we're calculating. Okay, that's it. Just to add something here, usually we have hermetically sealed compressor wherein it's already sealed. I've googled this one. A hermetic or sealed compressor is one in which both the compressor and motor are confined in a single outer welded steel shell. Yeah, the motor and compressor are coupled in the same shaft. So you have all-in-one unit here that has the compressor. But that doesn't mean that. So yeah, here again is the same example here. This time around we're calculating the minimum. A while ago we just calculated the maximum just to compare. So minimum size overcurrent protection device is 35 amps, now 45 amps. So you have a choice between the two. Which one do you choose? Well, I'll probably go with the highest one so that you won't have any problem when the air conditioning unit starts. Because if you go down too much, there's a problem that's going to cause the breaker to trip during the starting period, and it's not good. Okay, I think the caption here is okay. What's the reason behind this? There's a lot of reason. We've been talking about the code, but theoretically, let's find the reason why. Here we have a graph called the time current curve, and every components in power system tends to have this. Like for example, you have a motor here. This one is a motor, where technically air conditioning unit is like a motor too. Almost the same principle as that. Uh, at first, at 0 seconds, let's say 0 seconds, let's say this one is 1,000 seconds, I guess. Oh, great. Okay. Usually this graph is in logarithmic. And then for this one on the current, we have a current of 0 amps here. Going up, then let's say 1,000 amps, if it's not too much. Okay. The motor here has a time current characteristic curve here. So usually at 0 seconds, the current is too high, around 6 times the rated current of the motor. Yeah. So usually it's here. And then as we go through time, let's say at around 5 seconds, it's going to start to wind down until it reaches the normal load current. This is the full load current now here. So starting current here. So yeah, it's going to start for a few seconds, let's say around 5 seconds, 2 seconds, let's say. Just a hypothetical example here. Then we have the circuit breaker that we're talking about here. The circuit breaker here. The circuit breaker also has its own time current curve characteristic here. And usually inverse time circuit breaker. When we say inverse time circuit breaker, it's also specified in the code for motor loads. The higher the current, the faster it will trip. That's why if you look at it, if your current is around, let's say 1,000 amps, the time is almost 0. Okay, it trips almost instantaneously. Okay, let's say this is a 2-second mark here. Okay, so what's the problem with this? Remember when we size for a normal load, we size only 125% of the full load current of the rated load current. But for motors, when we size the circuit breaker of that, we usually ramp it up to 250%. And for air conditioning, that's 175 to 225% of the rated current. So if we size it at 250%, let's say this one is 250% here, then we're good. Okay, this is usual for motors. Okay, but what if we size these at a different value? Let's say 125%. Of course, that's going to shift here. Okay, that's why there's going to be an overlap here. Remember, this is a circuit breaker, and everything that is on the right of it, on the right of that, it automatically trips any value of current. And since the value of the starting current is here, then it's going to trip, since this one is on the tripping range. Okay, that's a tripping range there. It's a basic term. Okay, now going back to the theory of the air conditioning unit, it's the same thing. We have the starting current here, and then if we size it at around 250%, then the breaker is here. Okay, but if we size it, let's say 225% for the air conditioning, but if we have it at around 175%, that would most probably fall around here. So yeah, it's going to trip here. So your circuit breaker is going to trip when the motor starts. Okay, that's the basic rules of it. So I guess that's all you needed to understand. If you don't understand this graph, that's okay, we can make a separate video of that. What's important is that we have answered the question, is 10 gauge wire okay for a 50 amps breaker? Absolutely, as long as it's what the manufacturer says, or that is what you have calculated based on the standards set by the code. Okay, so we're good at it. Thanks, guys. See you again tomorrow. Just a little bit with regards to the experience of Mr. Sparkys Roy. This is his experience regarding this problem, wherein you have a small wire compared to a breaker. Yeah, do that. My dad's old school. When I first told him a while back, he was stunned. He was like, "You sure?" Oh yeah. So 30 amps, 10 gauge, 20 amps, 12 gauge, 15 amps, 14 gauge. That's the small conductor rules. But as I said, we're not going to apply small conductor rules for air conditioning unit. Okay. And then another story behind this is, I told you another one I did, a welder hook up a good size Miller unit. I actually called the manufacturer, talked to the department that handles the install and the specs for that machine, and it was like 120 amps breaker on a 6 gauge. Talking about eye opener, huh? So just imagine we have a welder. Okay. Well, of course, they're covered on the book. So remember the value, it's 125. Let's write it here. 125 amps breaker, circuit breaker here on a 6 gauge wire. Let's see the ampacity for that by sliding back to the book. Okay, let me see here. So you can see 6 gauge wire here. 6 gauge wire. Oops, I don't have, but most likely it's here. I forgot to put it here. But look at the range, it's 40 and 50, most probably around 60 or 70. Yes. So just imagine having a 6 gauge wire on a 125 breaker, and it's still compliant with the code. That's what I'm talking about, man. That's so great. Thank you, Sparky Troy, for that experience. Really appreciate it, man. Even I have used really small wires compared to the breaker size. So I hope this clears everything. And if you need any suggestions, comments, or you have any what you call these things to add up to our um, topic today, just let me know. I'm free to DM here. Uh, we're open, and I hope you reach out. Yeah. Thanks. Okay. Shout out too to Erickson Lee and the owner of Erickson Construction. And it's really a great one. I'll do a review video. I forgot, man. Thanks.